Salam, peace be upon you. My name is Muhammad Laiq Siddiqui, the father of Holophase. Remember the language we are learning. There is one field, phi, the holophase, one continuous cyclic movement from which all of reality unfolds. When phi begins to change, its first derivatives appear, and with them the three dimensions show themselves at once. Time as omega, space as k, and motion as v, built from both together. Every higher derivative is a finer question about how phi changes, and each one casts three shadows together: a time shadow, a space shadow, and a motion shadow. These echoes mix and weave into one another, forming the patterns we call fields, particles, bodies, thoughts, and worlds. In this picture, everything that exists is a living tapestry of phi, endlessly echoing through its derivatives and their dimensional shadows. Today, in the final part of Episode 8, we step back and look at the whole picture. We are not yet building a universe. We are not yet talking about forces, particles, or experiments. In Episode 8, we have done something even more radical and more quiet. We have described what the language itself is before it writes any world. In this part, I want to walk you through that whole story again, slowly and simply, as if we are standing on a hill and looking back over the landscape we have just crossed. Think of phi as a pure language that exists before any book. Most of the time, when people talk about reality, they start with things: atoms, fields, space, time. In Holophase, we step behind all of those and say, imagine there is only one smooth, cyclic field, wrapping around like a phase on a circle. This bare object phi is not yet a particle or a wave. It is just a rule that assigns a phase value to every point of some abstract stage we call a manifold. Like ink that has not yet formed words, phi is a pure mathematical creature. This brings us to the first backbone of Episode 8, the difference between language and book. The language is the whole system of symbols, grammar, and possible sentences. The book is one particular story written using that language. In our story, phi language is the language. Any concrete universe, with its galaxies and particles and living beings, is just one very special book printed in that language. Episode 8 is about the language itself, without committing to any particular book. Then we realized something subtle and beautiful. Phi, in this abstract state, is pure potential. If phi does not vary, nothing is written. An absolutely constant phi is like an empty page, or a frozen note held forever with no melody. All the richness comes from the way phi changes. The moment phi begins to vary, the alphabet awakens. But in Episode 8, we deliberately stayed one step back from physical change. We said, let us talk about the structure of variation itself, before saying what it describes. From here, we introduce the simplest symmetry of the language, shift symmetry. If we add the same constant to phi everywhere, nothing important changes. The melody of the language lives in the intervals, not in the absolute level. Just as you can shift an entire piece of music up or down the piano and it is still the same song, you can shift phi and still have the same structure. This teaches us a powerful lesson. The language only cares about differences, not about some absolute zero of phase. We also chose the shape of the value space of phi, a circle, S1, not a line. Why does this matter? Because a circle closes. If you keep walking around, you eventually come back to where you started. This circular nature is the seed of oscillation, of periodicity, of winding. You can imagine phi as an angle on a clock face rather than a mark on an endless ruler. Already, before any physics, we see why cycles and phases are so fundamental. They are built into the very space of possible values. Once we had phi as a cyclic field, we asked the most natural question: how does phi change? Every answer to that question is a derivative. A derivative is a tiny comparison. What happens to phi if I move a little bit in time or a little bit in space? In Episode 8, we treated these derivatives as the alphabet of our language. They are letters without reference, pure symbols that tell us how phi bends, twists, and oscillates. We organize this alphabet into a hierarchy. First-order letters like omega and k, and d, phi, and v are the basic consonants and vowels. They tell us about the simplest changes: how fast phi turns in time, how fast it twists in space, how it slides along its own crests. Second order letters like alpha, acceleration, curvature, and divergence are nuance letters. They tell us how those changes themselves change. Higher orders go on without end, like a ladder of ever finer questions asked of the same underlying movement. At each point, if you collect all possible derivatives of phi, you get something we called the infinite jet, J infinity phi. You can think of this as the complete local dictionary at one point, every derivative of every order in every direction. Mathematically, if you know this enormous stack of answers, you can reconstruct phi in a neighborhood around that point. Conceptually, it means that all local structure is already sitting inside this dictionary of change questions. We also made an important move about units. We did not start with meters and seconds. We started with abstract axes of variation. Radians simply count how far around the circle S1 we have moved. Time, space, and motion are projection directions, ways of slicing the same derivative structure along different interpretive axes. Units, in this abstract episode, are not physical tools. They are labels for how we are reading the pattern of variation. With the alphabet in place, we turn to grammar. Not every mixture of derivatives is allowed. Just as you cannot string words together in any random order and still get a meaningful sentence, you cannot assign arbitrary derivative values and still have a consistent phi behind them. Equations like partial t of k plus gradient of omega equals 0 appear first here as pure grammar rules. They say that certain combinations must balance so that a single underlying phi can exist. This leads to integrability. The deep question: do these derivative answers come from any actual phi at all? If the answers contradict one another, there is no story. You simply have an impossible set of demands. This is crucial. The language is built so that contradictions do not produce paradoxical worlds. They simply mean no such phi, no such sentence. Inconsistency is silence. We also recognize that the grammar of phi is not just simple and local. It spans a whole hierarchy, from regular linear constraints to nested, context-free structures, to fully context-sensitive global conditions that involve topology and action. This is important for later because it means the language is rich enough to carry everything from simple waves to tangled field theories, and possibly even conscious structures, without ever leaving its own alphabet. Then we shifted to topology, how the language behaves when smoothness fails. There are places where no matter how you change coordinates, phi cannot be made smooth. We call this set sigma. These are the grammatical boundaries, the punctuation marks where sentences tear. Not yet physical defects, but markers of where the smooth part of the language ends and something more knotted begins. On a circle, something magical happens when you walk around loops. You can count how many times phi winds around S1. This winding number is an integer that falls out of a perfectly continuous structure. Without invoking any particular physics, we already see how discrete labels like charges can arise purely from the topology of the value space. A smooth phase field quietly hides the exact whole numbers inside it. When several of these boundaries and windings exist together, they can tie themselves into knots and braids. Knots are closed loops of sigma entangled in space. Braids are the histories of these defects weaving around each other in time. The way they link and cross is like a topological grammar, a higher-level word formation process in the language of phi. Later, these structures will map to stable physical entities, but here they are just patterns of entanglement in the abstract script. Holonomy added another layer. The language can remember where you have been. You can travel in a loop through a region where everything looks trivial locally and still come back shifted. The path you took matters. This is a kind of semantic memory built directly into the structure of phi, a way for history to be written into the fabric of the language itself. After alphabet, grammar, and topology, we asked, what is meaning if we do not yet point to any external object? In Episode 8, meaning is internal. It lives in the relations between symbols. You can fully analyze the grammar and structure of an invented language, even if it does not describe any real world. In the same way, phi language has internal semantics. Patterns constrain one another, depend on one another, and that web of dependence is what we call meaning at this level. We then reframed time, space, and motion as three projections of the same structure. Given the full pattern of phi and its derivatives, you can read it as a story in sequence, time-like, as a pattern of coexistence, space-like, or as a dance of transformation, motion-like. These are not three separate ingredients. There are three ways of looking at the same script. This triunity is one of the deepest ideas in Holophase. Time, space, and motion are semantic roles, not independent substances. Quadratic forms, like omega squared or the squared magnitude of k, entered as measures of intensity. They tell us how strong a pattern is, how sharp, how pronounced. We did not yet call this energy. We simply treated it as an internal measure of how much of this change is present in a configuration. Action, S of phi, then appeared as a global score, a way for the language to prefer some sentences over others. The extremal sentences are the ones the language finds most economical, most elegant. Spectral modes gave us another viewpoint. Any phi pattern can be decomposed into pure tones of structure, like Fourier modes or other eigenfunctions. This gives us a basis set, a small alphabet of pure shapes from which any pattern can be composed. Again, this is purely abstract. No medium, no waves on water or air, just the fact that functions on a space can be expressed as sums of basic modes. Then we turn toward information. At this level, information is simply the narrowing of possibilities. A pattern of derivatives tells you what phi cannot be, as much as what it is. The more structured the pattern, the more alternatives are ruled out. Information is not a separate substance floating above phi. It is the effect that structure has on possibility. Complexity became how deep into the derivative tree you must climb to encode a behavior. Simple patterns can be described with low-order derivatives. Rich, intricate behaviors require higher-order structure. In your everyday life, you see this difference between a pure tone and a symphony, between a straight line and a fractal coastline. In holophase language, that difference is measured by how far up J-infinity phi you need to go. We extended this to memory as hysteresis, situations where the present does not tell the whole story, unless you know the path taken to get here. In phi terms, this is encoded as loops in derivative space that do not shrink away. The language itself can store history in its structure. From here, it was a small step to computation. We sketched how logical gates and state updates could be encoded in patterns of phi and its derivatives. The claim is bold but simple. There exists a sub-language of phi that can emulate any computation a Turing machine can perform. That means phi language is not only able to describe patterns, it can also implement arbitrary algorithms at the level of structure. In the later books, we revisited time, space, and motion in a cleaner way. Time became just ordering, what comes before, what comes after. Space became coexistence, what can be present at once. Motion became transformation, how configurations are consistently mapped into one another. Every pattern of phi participates in all three views. You can always retell the same configuration as a timeline, a spatial pattern, or a path of change. We asked whether such a language could contradict itself. The answer by construction was no. If you try to specify derivatives in a way that cannot come from any phi, you simply fail to define a sentence. There is no paradox in the world. There is only the absence of a valid configuration. At the same time, we argued that the language is complete in a precise sense. Any structurally well-posed pattern of time-space motion structure should be representable as some phi plus its jet. We also built self-reflection into the architecture. Phi can write about its own grammar. It can encode rules about its own rules. But there are Gödel-like limits. No finite list of sentences can capture all the truths of the language at once without running into incompleteness. This plants a deep humility at the core of Holophase. Even the universal language cannot fully compress itself into a single finite summary. Finally, we drew a careful bridge from pure abstraction toward physics. We distinguished between the timeless library of phi sentences and any real, noisy, approximate implementation in matter and fields. We spoke about the mapping problem, how we will later connect derivatives of phi to measurable quantities like frequencies, wavelengths, forces, and charges. We introduced the reality filter. Among all grammatically allowed phi stories, only a tiny subset will be stable, realizable, and observable as a physical universe. We also looked at knowledge itself as a pattern inside phi. An observer is a subsentence written in the language, trying to reconstruct the language that writes it. That means every act of knowing is partial, noisy, and based on truncated jets. Already in Episode 8, we prepared the ground for experimental protocols and error bounds while staying inside the abstract level. The last step of Episode 8 was to talk about representation freedom and canonical form. The same phi story can be written in many coordinate systems, with many different looking formulas. There is a whole symmetry group of transformations, automorphisms, that change the description but keep all the grammar intact. Two ugly-looking equations might secretly be the very same sentence, just written in different alphabets. To bring order to this, we introduced the idea of canonical form and the Holophase language standard. Among all equivalent descriptions, we choose one standard way of writing things: a fixed ordering of derivatives, fixed sign conventions, and compression rules. At the most abstract level, a sentence in phi language is not a single formula, but an equivalence class of all formulas related by these harmless rephrasings. All of this is still before physics. We have not yet chosen a particular book to write. We have only finished designing the language in which any such book must be written. In Episode 9, we will finally let the language start writing. We will talk about initial conditions as first sentences, about production rules that generate waves, defects, and fields, about how real physical laws emerge as specific grammatical habits of phi. But everything that comes next depends on what we have done here. So as we close Episode 8, hold this simple image in your mind. One cyclic field, phi, living on a manifold, with an infinite hierarchy of derivatives that act as letters and words and grammar. Topology, information, time, space, motion, and even computation are not external add-ons. They are all shadows and structures of this one language. Everything that exists in the Holophase view is phi speaking. Episode 8 has taught us what the alphabet and grammar of that speech must be before a single universe is uttered. Before we move on, I want to leave you with a few very concrete images you can return to anytime you feel lost in the abstraction. First image, a library with no books yet, only a perfectly designed language. Imagine walking into a vast library where every shelf is empty. There are no novels, no textbooks, no poetry. But on a single table in the middle of the hall lies a complete description of a language: its alphabet, its grammar, its dictionary, its rules for writing and combining ideas. You could, in principle, write every possible story in that language, but none have been written yet. Episode 8 is that document on the table. Phi is the language. The possible universes are the unwritten books. We have spent this whole episode studying the language manual before we let a single story appear on the shelves. Second image, a piece of music that exists before any performance. Think of a symphony written in perfect notation, lying silent on a stand. The paper is still. The air is quiet. Yet everything about the music is already there. The notes, the harmonies, the rhythms, the crescendos. If you know how to read notation, you can almost hear it in your mind. Phi and its derivatives, its jets and modes and actions are like that silent score. The actual vibrating strings and air and eardrums belong to physics, to Episode 9 and beyond. Episode 8 is the score itself, the pure structure of the music, independent of any orchestra. Third image, a programming language before any program is written. You can specify the syntax, the keywords, the data types, and the rules for how instructions behave. You can even prove that with this language, you can compute anything that is in principle computable. But until someone writes code and runs it on a machine, nothing happens in the world. Phi language in episode 8 is that kind of programming language. The universe, in later episodes, will be one particular program written in it and executed by reality. Now connect these images back to some of the technical pieces. The infinite jet, J infinity phi, is like having not just a dictionary of words, but a dictionary that tells you, at each point in a story, how every possible way of continuing behaves. Knowing all derivatives at a point is like knowing, for every possible small move, exactly how the sentence will bend if you push it in that direction. It is an insanely rich local description, and yet it is still only about structure. Topology, with sigma and winding and knots, gives you the punctuation of the language. Most of the time, sentences flow smoothly, word after word. But sometimes you need commas, full stops, question marks, and even gaps where something unsayable sits. Sigma marks where the smooth sentence breaks. Winding numbers are like page numbers or chapter numbers that you cannot erase by rewriting the text in a different font. Knots and braids are like recurring plot lines that weave through chapters and cannot be removed without changing the story at a deep level. The triunity of time, space, and motion can be held in a very simple daily analogy. Think of watching a film. You can focus on the sequence of frames, what comes before and after. That is the time-like view. You can freeze one frame and look at where everything sits on the screen. That is the space-like view. Or you can follow the movement of a character across many frames. That is the motion-like view. It is always the same film, the same underlying data. You are just choosing a different way to pay attention. In Phi language, the same underlying pattern can be reread in these three ways, and none of them is more fundamental than the others. Action and optimality may sound abstract, but you meet them every day in your own behavior. If you have to go from home to work, you do not explore every possible path. You pick one that is good enough, short, safe, familiar, maybe also scenic. You are informally minimizing a kind of personal action, a cost function made of time, effort, risk, and habit. In physics, the action S phi plays a similar role. It encodes which phi sentences are favored. In episode 8, we strip that idea down to its bare bones. Before, it is about particles and fields. It is just the statement that among all grammatically allowed sentences, some are marked as more economical than others. Information and complexity also live close to your experience. When you play a guessing game, I'm thinking of a number between 1 and 100. Every answer you receive rules out possibilities. If someone says too high or too low, your picture of what the number could be shrinks. That shrinking is information. In Phi language, every additional constraint on derivatives, every relation like this must equal that, chops away possibilities in the space of configurations. Complexity, on the other hand, is like the length of the explanation needed to describe the answer. Simple answers have short explanations. Complex ones need long stories. In our language, complexity is measured by how deep and intricate the derivative structure has to be to capture a pattern. Computation universality might sound like something only computer scientists care about, but it is deeply tied to the claim that phi is a truly universal descriptive medium. If, using patterns of phi and its derivatives, you can in principle implement any algorithm that a Turing machine can run, then nothing about information processing lies outside this language. Any process that can be modeled as a computation lives inside Phi language. That is why later, we will be able to talk about brains, machines, and even entire ecosystems using the same underlying scripting system. One of the most important threads running silently through episode 8 is falsifiability. We are not just telling a pretty story about language. We are saying, if reality cannot be phrased in this language, then this whole framework is wrong. If we ever find a phenomenon that stubbornly refuses to fit into phi plus its derivatives and topology and actions, then we do not patch the phenomenon. We admit that our language was not universal after all. This is what makes Holophase a scientific proposal, and not just a philosophical poem. Every layer we built in episode 8 comes with an edge where it could, in principle, be broken by the world. It is important for you as a listener to feel that openness. We are not forcing reality to obey phi. We are inviting reality to judge phi. Episodes 9, 10, and beyond will move more and more into that testing ground, deriving concrete wave equations, field behaviors, and experimental predictions that either match our world or do not. But the honesty of those later chapters depends entirely on how clearly we have drawn the language in episode 8. So if you feel that some parts of this episode are heavy or abstract, remember why we are doing it. We are building a single, clean, maximally simple way of talking about time, space, motion, information, and structure. Once you fix that language, you do not get to change it later without admitting you were wrong. That is why we took such care to define the alphabet, the grammar, the topology, the semantics, the information theory, the dimensional roles, and the symmetries of phi before even mentioning a specific physical law. As we leave episode 8 and walk into episode 9, keep this in mind. We are not starting a new story. We are just beginning to use the language we have now finally understood. From now on, every time we talk about waves, defects, fields, forces, or even consciousness, we will be speaking in phi sentences, using the alphabet, grammar, and symmetries you have just heard described. If at any point in the future you feel lost, you can always come back here, to this episode, and remember, behind every equation, there is just one smooth, cyclic field, phi, defined on a manifold, taking values on a circle. Behind every complicated term, there is just a derivative asking, how is phi changing here? Behind every topological twist, there is just a story about how that change wraps and knots and remembers its own path. Episode 8 has given us permission to take that seriously, to treat phi language as a real, testable candidate for the deep structure of reality. From the next episode onward, we will start to see what happens when that language is allowed to speak the universe into being. Episode 8 is the silent blueprint beneath our journey, the calm, precise drawing before the universe begins to move everywhere.